Okay, everybody, welcome back to Isco Insights. So good to be here. It's been a bit since we've been able to do one of these. Thanks so much for joining today. My name is Will Vodak. I'm a business manager here at Isco Industries, and we've got a ton to cover today on butt fusion. I know you've heard a lot about this. We preach it all the time, but this is one of the most fundamental components of using HDPE. So we're really excited to bring you the full butt fusion experience today from start to finish. So a novice like myself sometimes needs a little bit of help. But before we get into that, we're going to go tackle these instructions here on how to use this webinar format on Zoom. All your audio and video is off to enhance our quality. Don't worry if you're sitting at home on the couch in sweatpants, we're not going to be able to see you. For any feedback or troubleshooting with Zoom, please go ahead and use the chat feature. We will do our absolute best to try to help you out. But most importantly, I'm sure you're going to have some questions along this journey. So please use the Q&A tab below on that panel of options. Click that Q&A button and submit your questions, and we will do our best to answer those in real time. So as I said, I need some help with everything. So they called in the backup, the big guns, the first big gun plane injured, my friend, my co-host, Mr. Gary Bouvet. Gary, how you doing today?
Will, always good to be here, man. It's another warm day here in the city of Louisville, and I'm excited talking about fusion. I mean, it is one of the key aspects that make HDPE such a great product to choose. So I'm really ready to dive into this today.
This is something that Gary wakes up every morning and just wants to talk about fusion. So Gary, for those that don't know you, I find it hard to believe anybody doesn't know you. But who are you and why should people listen to you?
Well, I am a project manager here at Isco Industries. That's kind of a broad term. I get involved in a lot of different things. I've talked about HDPE and fusion all across the world, and for over 25 years here at Isco, Will. So been doing it a long time. I'm always excited about talking about it. So I'm ready to get moving.
Fantastic. And even Gary needs some help from time to time. So we brought in our real specialist in this, Eric Ray, with us from one of our yards out in Louisville, Kentucky. Eric, how are you doing out there? Can you hear me? We've got Eric muted. I'm wondering if someone can, over at the Riverport yard, could unmute Eric's microphone so we could get him going. There we go. Eric, let's try this again. Second time. How you doing, my friend?
Hey, Gary, Will, how are you guys? I'm doing great. Hello, everyone.
So we chose Eric for this not only because he looks like Bradley Cooper, but he also has the experience to walk us through this fusion demo in full. Eric, why don't you give us a little bit of your bio and background in this industry? And I always ask the question, why should people listen to you today?
Yeah, so I've been with Isco for about 6.5 years. I'm a maintenance manager over the rental and refurb here in Louisville and Huntsville, Alabama. We work on a fusion from.
You deal with this equipment all the time. So tell us a little bit about what the fusion equipment is behind you. Is there a name for that particular beauty back there?
Oh yes, well this is Margaret. See, and Margaret's in a great mood today.
Well, we're excited, Eric, to get this going. So let's kind of just start this off. Eric, I think you guys are going to actually show us kind of start to finish. The goal of this really is to show a fusion from the very beginning through the very end. So Eric, do you want to maybe start us off and tell us a little bit about loading that pipe itself and things that you look for when starting off a fusion?
Sure. So today we're working with 12-inch pipe DR17. We've got a 40-foot section loaded into the fixed side of the machine. What we're going to do, we've got a piece of pipe slinged, another 40-foot piece of 12-inch DR17. So we've got it slinged, and we've got a man with a tack line on the opposite end, and we're going to be loading this into the machine to make a joint today.
Fantastic. Well, why don't you guys go ahead and start that process. As you do, Gary and I are going to talk a little bit about fusion in general. namely what is fusion? So Barrett, maybe if we could get the full picture of the fusion going, we'll talk a little bit about fusion, Gary.
Yeah.
First off, what is fusion and why is it so important to what we do here at Isco?
Well, I mean, fusion on the true definition, you look up in Webster's dictionary, Will, I don't know if you've used one of those recently, but you can go in there and find the meanings of words. And fusion is the occurrence involving producing or production of a union. It's also the state of being combined into one body or the act of melting together. Well, we're encompassing all three of those into this process of joining HDPE pipe.
And the reason we're doing that, Gary, is to create a monolithic system. We're constantly getting this question is,
Pull it that way.
well, how do you join it? We join it via fusion, and then after we do that, that thing's not coming apart, correct?
Exactly. Fusion is, we're making two pieces and basically creating one. We're taking those two pieces that we're fusing together, and it becomes one piece of pipe, and it functions as one piece of pipe. And if we do that over 1,000 foot, it's 1,000 foot piece of pipe, essentially.
Not a bunch of separate pipes, if you will.
Absolutely.
So Gary, talk to me about what the principle of heat fusion is. We've kind of touched on what fusion is, but what about heat fusion for polyethylene specifically?
Right. So the fusion process for polyethylene involves two key elements, heat and pressure. And so that heat is necessary to melt the ends of the pipe, and then the pressure is necessary to interlock those molecules of those two separate pieces into one continuous piece of pipe.
So essentially, is there any difference between that molecularly, between the two different pieces of pipe coming together?
There's no difference between those two stationary. Now, we alter that molecular structure, Will, when we apply the heat to it. So we take it from a very crystalline state, which is solid, into a very amorphous state or molten state where the molecules and everything are very pliable and flowable.
Right. And Gary, one last thing. Obviously, you need a combination of pressure to be able to make that joint.
Right.
Right. If you just bring two heated pipes together and kind of just touch them together, it's probably not going to do much. But in order to make that fusion, you really need some pressure from that as well.
Right. And that pressure is predetermined by the size and DR of the pipe. So that pressure is going to change based upon the size of pipe that you're doing.
Heat, pressure, and time, Gary. Speaking of time, it looks like Eric just completed that while we were talking a little bit about fusion. Eric, you seem to do that really safely. That's obviously the key here. Anything that you recommend from a safety element that's going to be in the front of our minds all day long. But I noticed you guys were using some taglines there as well.
Yes, sir. So it's important to keep your hands clear of any pitch points when the pipe's coming in. It could be swinging. So you want to never put yourself between the pipe and any other object. So you want to protect the machine. So you want to lift the pipe high enough to clear the cowlings and all those important components that we're going to be using here, and keep those hands free. If you've got to touch the pipe, but not on the ends. You don't want to get your hand pinched in there between the jaw or between the other pieces of pipe.
And Eric, you had some help as well. Is it always a good idea to have multiple guys taking a look at things from different angles to make sure everyone's safe?
Yes, sir. So on the opposite end of the pipe, we had a tag line, which is basically a length of rope or anything that you can find to be able to, when that pipe's strung in the air, wind, other objects, if it does bump anything, it can get out of hand. So you want to make sure that you have some control, at least on one end of the pipe. And then the operator, being myself, I can control the pipe coming into the machine on my end.
So, Eric, we're going to let you get into position for this fusion. I think we got to get some close-up shots. While we're talking about that, Gary, butt fusion is, or while we're letting Eric kind of get set up, butt fusion is a step-by-step process. So really, combination of these 7 steps will make a successful butt fusion. It's so easy, even someone like myself can do it. So do you want to maybe go over these steps as a whole, just very briefly naming them, what we're looking for, and then we're going to go in step by step with Eric out in the field.
Right. So we've got the clamping part. So he's loaded the pipe in. it looked like, Will, he already had the pipe clamped down. So that's step one. And that clamping is just to secure the pipe safely so it doesn't move while we're doing the actual fusion steps. Then the second one is alignment, checking his high-low on his pipe. Then we've got facing, where we're squaring the ends of the pipe. Then we've got heating, which we're melting the pipe ends with the heater. And then joining the pipe, which is utilizing the pressures that we talked about earlier, pushing those two molten ends together, and then cooling them, and then inspection. So those 7 steps are the same, whether you're doing 1/2-inch pipe or 65-inch pipe. The steps are the same. The only thing that changes, Will, is the mechanics of the equipment.
So it looks like Eric is starting this. Eric, can you hear me out there?
Yes, sir. So I'm
Eric,
getting ready. I'm prepping the pipe to be faced off.
So Gary, you were
Sorry,
touching on.
can you hear me?
Yes, we certainly can. I think you're a little bit ahead of us, but that's okay. We'll catch up to you. Gary, you want to talk a little bit of while we're looking at this? Eric clamped that pipe beforehand.
Yep.
Using some of those hydraulic controls there.
Yes, absolutely. He's got a hydraulic clamping kit on those jaws, so that really makes that a very efficient, quick process. Other machines are manual tightening of each of those clamp knobs, but in this particular case, he's just simply clamped that pipe that holds it in place while he does the other fusion processes. He's got the facer in there now, Will, so he's already getting ready to do that facing. This process is necessary to square the pipe ends, remove any oxidation layer that's on the pipe, getting down to that virgin polyethylene, which really helps with heat penetration when we're ready to put the heater in.
So before we face, Gary, we're going to check some alignment on those pipes and make sure that everything is coming together. Eric, can you show us what that would look like to maybe bring those pipe ends together, check for high-low, and just to make sure that clamping was done correctly? I think you're also going to look for some slippage there so that when you bring those pipe ends together, you're not going to have the jaws maybe slip out of line.
Yeah,
absolutely. So right now, I'm also setting my drag pressure on what it's going to take to move this pipe. So, and then we'll bring the pipe together, check alignment.
Yeah. So that drag that he's doing, Will, is really important, particularly if you're doing tie-in welds. You've got long strings of pipe out on each end, and you're trying to move that pipe together. You have that pressure. There's a lot of load on those jaws. So we have to add and compensate for that into our pressure settings and so forth. So he's doing that drag calculation check right now.
And that's just the amount of force it's going to take for that pipe end to move so it doesn't creep away from that heater plate.
Right, exactly.
So Eric, how's that alignment looking to you? I noticed you were checking that out for about up to 10% of the wall thickness. Does that look pretty even to you?
Yes, absolutely. We're looking good. We're within that 10% for sure.
You know, Eric, if there was a little bit of a high side, you, Gary, tighten down that high side rather than loosen up the opposing side, correct?
Absolutely. Now, with
yeah,
with this,
so the,
go ahead, Eric.
So your inner jaws having okay, sorry about that. The inner jaws have an adjustable clamping cylinder, where your inner jaws are for height adjustment. Your outer clamping is more for gripping the pipe. So if you do have an offset or a height adjustment that's needed, you can do that with either side of the inner clamp cylinder.
So Edgar is asking a really good question. What do you mean by 10% of the wall thickness? So Gary, what we mean by that is 10% of the interfacial area of that pipe, really. So it's, let's say the pipe thickness is 1 inch. You're looking at 10% of 1 inch for high or low.
For a high low that you can be off, doesn't have to be perfectly aligned. So 1/10 of an inch, right, is what we'd be looking at in that case, Will, with a 1 inch wall thickness.
Keep the questions coming, Edgar. We appreciate them. Barry, let's go back to what Eric is checking out. So now we're going to go into this kind of next phase. Once we have aligned this pipe, which is what, Eric? What's the next step here?
Yeah, so now that we know our drag pressure, we'll need to calculate based off of our 12-inch pipe DR17. Gary, what's going to be our calculation if our drag pressure is 60 PSI?
60 PSI, your fusion pressure is going to be at 443.
And for our audience, Gary
All
is
right.
not doing that math in his head. He doesn't know, he knows a lot, but he doesn't know the actual drag pressure of every single size range.
Yeah.
But Gary, tell us about that McCallican. And
Yeah,
how you
I
come
mean,
to that.
so as with anything, Will, right? Everything's got an app for it. There's an app for being able to calculate your fusion pressures. And I happen to have that on my phone, and I've plugged in the information that Eric has shared with me about the pipe size, the DR, chosen the right machine that he's working with today. And we've calculated all that up. The standard fusion pressure for that size of pipe is 383. And then when he adds that drag to it, that's where we have the 443.
And the audience can see there what looks like an iPad connected to that machine. Eric is using what's called the data logger. That data logger is connecting into the machine, and it's reading in real time the PSI output that the force is that machine is giving. So Eric is dialing in all three of those selector valves to the appropriate pressure right now, Gary.
Yeah, incorporating the drag that he had on there, Will.
So Eric, it looks like all your pressures are set. I think we're moving on to facing the pipe. Is that the next step?
Yes, sir. We're ready to face off some pipe.
So while Eric's doing that,
So we're going to switch our selector valve.
Go ahead, Eric.
So we're going to switch our selector valve to facing pressure. Now, don't forget that there's drag pressure. So we're going to need at least that 60 PSI to drag this piece of pipe. But you want to face under the lowest possible setting. You guys
So
see
what
that
Eric-
heater move on its own?
Yeah. What Eric is talking about is facing off. And Gary, let's back up a little bit. Why are we facing pipe? I mean, people might say, well, this seems crazy. We're taking pipe off, but there's a good reason for that.
Yep. It's, we're removing that oxidation layer, Will, getting down to the clean virgin polyethylene, but we're also squaring both ends because that facer has blades on both sides. So it squares the two ends together. So when they come together against the heater or against each other when we're doing the fusion, they're perfectly lined up and they're going to mate up properly.
So you'll notice Eric is
Okay,
dropping
so I've got.
Sorry, Eric. I know you've got a hard
So I've
time
got
hearing out
the,
there because of the machine, but keep going, man.
So we've got our facer in, and keep in mind your drag pressure was 60 PSI. So you're going to need 60 PSI to drag the pipe, but to face off the pipe, you want to face at the lowest possible pressure. Be sure that the selector valve is in facing pressure position. So it's going to be all the way up, and we're going to close the gap. We're going to bring the pipe ends together against the facer, and until the pipe reaches the facer, then we're going to turn the facer on and let Margaret go to work. You might have to slightly increase the pressure once it starts facing, but you just gradually want to increase that pressure. Nothing drastic. Inside that facer is a sprocket and chain driven by a hydraulic motor. So you only want to increase enough pressure until you start seeing a full ribbon.
Now, Will, there's what we call facer stops on the machine and the facer. And there's a gap right now between those facer stops and those jaws. And we want to take that gap out. That ensures that facing is done squarely. Both ends are squared up properly and the facing's completed.
So we're taking off some ribbons here. The reason we're doing that at low pressures, and it's really important, by the way, from a safety element, to turn that facer off before you stick your hands in there.
Absolutely.
And get those ribbons out. I don't know, can we zoom in on that pipe wall to see how essentially smooth, shiny, and square that is once we're complete? But essentially, we are taking off this to make sure that we're getting the best form of pipe into that area. So we've got a couple questions here, Gary. Solomon's asking, is this facing done for all sizes of plastic pipes or just large plastic pipes?
It's a great question. It is a key component for any fusion, regardless of size. We're always going to face the ends of the pipe off. They've been exposed, they've been outside. We want to get good heat penetration and get a good fusion bond. We always have to prep that pipe by facing the ends.
Mike's also asking, how much pipe do you leave sticking out past the pipe jaws?
Oh, that's going to vary, Mike, by job to job and depending on the condition on the ends of the pipe. Very commonly, we want about a thumb's width away from the jaw of pipe protruding in. But if you've cut that pipe, let's say with a chainsaw or some other thing where the cuts are not necessarily square and uniform, or the pipe's been damaged a little bit, nicked up, something's hit against it, we're going to have to take off more to make sure we take out any of that damage on the end of the pipe and get down to the clean, full face of that pipe.
And Gary, my good friend Wade is asking, assuming the pipe ends are relatively square, how many mils are removed during that facing process?
Boy, each ribbon is about a 32nd of pipe, 1/32 is how much we trim off. I've had jobs where I've had to take off, a quarter of an inch, half an inch in some cases, again, depending on damage, gouging on the end of the pipe that I've got to remove before I can do my fusion. So it really is going to vary from each particular job. But if this pipe has come from the plant, it's got nice, clean cut ends, we're not taking very much off. We're taking off less than a quarter of an inch of pipe.
And now looking at that pipe, it is perfectly seated. Eric, you've done a great job facing that. I see no gaps, no light coming through those pipe ends. It looks so good. It's almost like Gary did it. So Eric, now that we've faced the pipe, the next step really is to what? I think that's checking our heater plate, isn't it?
Yes, sir. Yes, sir. So we got our heater temperature set. We're going to check that and confirm our temperature is still good. So I've got a pyrometer.
Yeah, don't put your finger on that,
Get
Eric.
it out of my pocket. So we don't have any eggs or pancakes to put on here. So we're going to check this down just a bit. We're going to check our heater temperature. And what we're looking for is between 400 and 450. So we're over 400, and you want to check it at multiple points. Generally, 12 o'clock, at 6 o'clock, 3 o'clock, and 9 o'clock on both sides. Confirm that your temperatures are good. And we are good, cooking at about 403, between 403 and 420.
So Gary, what is and something we're going to mention here in a bit is this is all guided and governed by the ASTM F2620. What does the 2620 document say about heater temperatures and temperatures that we're allowed to butt fuse at?
Well, that heater temperature, so, they have that range of 400 to 450. The optimum target that we're always looking for is around 425. But successful fusion polyethylene has a high variability with it. So we've got that range of 50 degrees that we can work with in terms of heater temperature.
So Eric has gone ahead and begun that fusion process. So we are now heating this pipe up. So Eric brought all that pipe together under a brief amount of pressure. And there you just saw what's called the shift sequence. Gary, do you want to talk more about that shift sequence? It always seems to mess me up, but that's not too hard to do.
Yeah, the shift sequence on any of these hydraulic machines, right? You have to bring that pipe in, that movable jaw against that heater, and you have to bring those in contact. So something's got to move. We got to have pressure to move it. Once we bring that into contact, depending on the size of pipe that we're working with, we may do that shift sequence immediately, or we may have to do it after a little bit of time. We want to wait as our sizes get bigger, we want to wait, make sure that we start to see a melt forming on the pipes, that we've got good contact with that heater all the way around. Then we would then drop our pressure. So again, those steps vary slightly depending on size of pipe, but that shift sequence, what we're doing is we're getting all of the pressure out of the cylinder so that while that heater is against that pipe, it's under no pressure. It's just contact against the pipe ends.
So Eric, you've used that data logger, I see, to start your fusion. What is the data logger saying and keeping you on track for either the time or the bead size that you need to reach?
Right, so 12-inch pipe, you're really looking more for a bead size. And what it's showing me is I'm gonna need a 1/4 inch of a bead melt on both sides of the heater. So I'm looking for a 1/4 inch bead melt on the fixed side and a 1/4 inch bead melt on the movable side. So once we flip to neutral, we're now back to our drag pressure. So we're at that 60 PSI it took to drag the pipe. Then we shift to neutral. This way the pipe's not applying pressure to the heater, but it's not trying to float away either.
Yeah, and that melt time, he said he gave you a bead size, but we also referenced the ASTM standard, Will, and it says 4.5 minutes per 1 inch of wall thickness is our minimum melt time. So depending on weather conditions, sometimes we have to go longer than the prescribed time because we got to get to that proper melt bead size. So we're looking at both of those things, Will. Minimum of 4.5 minutes per inch of wall thickness of pipe, and the bead size of a 1/4 inch that he's looking for.
So this next step, our audience, I'm going to tell you, it's going to go pretty quickly. Really, the next step, and that's why we're going to jump ahead here to while Eric's watching that plastic melt. We're talking about joining the pipe itself. So Gary, what's going to happen here? I imagine he's going to remove the facers, remove the heater, check the ends to make sure that it wasn't heated under pressure. And then they're going to bring those pipe ends together after removing that heater.
It's all going to be very quick, as you indicated, Will. He's going to, before he gets ready to pull that heater out, he's going to shift down into fusion pressure because that's our next step. Plus, that's going to give us the maximum pressure to open that jaw quickly. He's going to open that jaw. The heater is going to be removed, and he's going to put it back into forward. He's going to bring those pipe ends together while he's looking at the melt, the formation of that melt, as you said, to make sure that it's been properly done without any pressure.
Eric, are you staying hydrated out there? Are you sure you're up for this?
I'm staying hydrated, sir. They've got a cooler out here. I won't talk about everything that's in it, but there's water in there.
So Eric, you're probably looking at right now between that 90-degree area between the pipe and the heater. Are you seeing that pipe grow at all? I know it's really hard for the camera to get in there, but you can probably see that, Eric, up close.
Yeah, we are. Right now, I would say we have about a 1/16 of an inch of a bead that's starting to roll up on each side. So we're just going to continue to monitor that. And when we get to around a 1/4 inch bead, and like Gary mentioned, we're talking about 4.5 minutes roughly. So I've got an eye on the timer, but also it's important that we've got a 1/4 inch bead there as well. So
great. Well, while you're waiting for that, we're going to take a couple questions here. Dinesh is asking, Gary, this is 400 to 450 degrees Fahrenheit, correct?
Yes.
Rapid fire, Dinesh. Thank you for a good question. Edgar, is the heater plate temperature typically checked manually like Eric just did, or can the machine record that in the data logger? Great question, Edgar.
So you will input the information into the data logger. but he has to do the manual check with the pyrometer.
Edgar, there's oftentimes a little temperature gauge on that heater plate. We really recommend taking a contact pyrometer, an infrared pyrometer, manually checking that, as sometimes that reading can be a little bit off.
Well, the gauge, the thermometer that's on the heater wheel that you indicated, reference is internal temperature. So when you've got wind conditions, different temperature elements, it can reduce that temperature. So we want the surface area to be checked because that's what's contacting the pipe.
My favorite person here today, the anonymous attendee, is asking how to determine face-off operation is functioning perfectly. Is there any rule of thumb, like after this much diameter of face-off, it has to be checked? I think we mentioned that, where if you're getting full ribbons removed from that pipe wall, then the face-off procedure is working as it should. You want to really, a rule of thumb there is if you're only getting a little bit of ribbons or shavings coming off from time to time, there's probably something wrong with either the facer blades or the facer itself. But if you're getting full ribbons and you're facing all the way back to the stops, that's a good sign things are working.
Absolutely. And if your cuts have to be square, right? Because you're squaring that pipe. So if you're only getting partial ribbons initially, it could just be that you had an angled or mitered cut on that pipe end wheel, and they're not contacting all the way around the facer blades yet.
Eric, I've got a question for you. Brian is asking, is there temporary power required for this unit? You want to talk about how this particular unit is powered?
Yeah, so this particular unit is a McElroy Trackstar 500. It's a Series 3. It's powered by a Kubota diesel engine. It's a 3-cylinder. And it's basically a direct shaft driven generator and hydraulic pump. The generator being on the front side of the engine and the hydraulic pump being on the rear side. So this unit is self-contained. You can track it anywhere, and it's going to be able to provide the electricity, the current that the heater needs to heat up, and also the hydraulic power to run the carriage, as well as the track vehicle itself and the facer motor.
So all of these units are going to be a little bit different in their operation. I think that's where, anybody interested in learning about the fusion process can reach out to the Isco salesperson nearest to them, and we'll be able to walk you through the many different types of equipment that are out there for you to be able to fuse.
Yeah.
Eric, are you getting ready to make this joint?
Yeah, I was getting ready to jump in there. We've got about a 1/4-inch bead. We're sitting at just under 5 minutes. So we're going to go ahead and shift into fusion pressure. Now, we only have a few seconds to get this done. So we're going to shift into fusion pressure. We're going to open the carriage, index the heater over, open the heater, get that heater out of the way, and then close it under fusion pressure. And there we have it.
So as I said, that occurred in pretty rapid fire succession, Gary, but what are we looking at here now? It looks like there's a bead formed on the pipe. Is that the case?
So you had 2 molten ends, Will, from that heater, right? And you've now put those under little over 400 PSI of pressure, and you've pushed those 2 together. So you've got what we call a double rollback, right? You've got both of those molten beads that have pushed and combined together and have also rolled back under pressure. And so what that did is took those molecules, and the molecular structure of polyethylene is very much like a chain. And so you've now taken all those different links of the chain and you've mixed them all together under this pressure. And now what you have is, and you're holding that pressure until it cools. That cooling process is about 11 minutes per inch of wall thickness per the ASTM standard. So at a minimum, we're going to hold that for around 11 minutes.
So this is my favorite part in doing these demonstrations because this is about as fun as watching paint dry here.
Yep.
Can we have the camera go back to that data logger if possible? There was a great shot of the data logger and the graph that we were witnessing. So if everyone can see this, I know the glare is out there. This is a great representation of why we're such big advocates of using the data logger, because the data logger can tell Gary if Eric is going to do this fusion correctly. at a minimum, Gary, what are you seeing here? If you were to look at this report, would you say that this was done by someone who is trained, experienced, and know what they were doing?
Yeah, it's pretty hard to see, as you said, Will. I think we've actually got a slide of a graph representation of a fusion in our presentation. And that really does, I could look at that and know if somebody followed the right procedures. Now, I want to make it clear that that data logger doesn't mean that you've all got a perfect joint. Because if somebody used an oily rag and wiped the pipe ends before he put the heater in there, the data logger is not going to see that. So the data logger eliminates, operator error in terms of pressures, times for both heating and cooling, but it doesn't, it's not 100% foolproof.
We've got a couple questions here, Gary, but before we do that, I'd like to take this opportunity to ask our first poll question of the day, which is, have you ever participated in Fusion certification training? Yes, your cert is up to date. Yes, but it's expired. No, you want to get certified. No, you have no need to get certified. Gary, I believe my card is expired. Is your card current right now?
Actually, I don't think mine is current, Will. I probably need to actually go through that again. So
I'd like to state here that this is great because we're talking in a very casual setting about the fusion process, about how easy it really is.
Right.
We're taking a ton of time to go through this, but you can see how quick this process can be if you do it correctly in repetitive motion. But Gary, there's really nothing to substitute a great training.
No, absolutely not. And we've got fantastic trainers all across the country who can come out and do the proper training, the certification, written test, fusion performance test that you have to go through before you get certified on that. And if there's any projects out there, we highly encourage anybody putting in specifications that they put in certified operators to do the fusion work.
Gary, I'd like to ask you a couple questions that we weren't able to touch on because that's such a kind of a time-intensive process. A lot of people use solvents like isopropyl alcohol and other cleaners to get that pipe clean. What are your recommendations on cleaning both maybe the pipe and maybe the heater plate as well?
So the heater plate has got a Teflon coating on it. If you're just doing proper day-to-day maintenance during your fusion where you're wiping those off before you put the heater in, each time, shouldn't really have too much issue. Where you start getting any buildup, discoloration on that, so maybe the Teflon's gotten scratched or nicked. Now you're down to the aluminum of the heater. Now you're going to get pipe that's going to stick to it. Those eventually are going to need to be replaced. That's the neat thing about the McElroy heaters, that those heater plates themselves can all be replaced easily. As far as the cleaning on the pipe, I'll only use the isopropyl alcohol if I know that I've touched that pipe. If I had chainsaw oils after cutting that pipe that's on the pipe surface itself, I'll take that 96% isopropyl alcohol and wipe the ends of that pipe off. But typically you don't need it because that facing does such a great job of getting down to the clean virgin polyethylene.
Yeah. Can we go back out to Riverport? Because I think we're gonna, Eric, you're very patiently like a bulldog watching that pipe cool. How is the cooling process going itself?
I'm sorry, I heard the bulldog part and I lost you after that. Can you repeat?
So right now you're watching that cool. We're about to take kind of a visual inspection of the pipe itself, Eric. So maybe if we could get back to that pipe, because we do want to look at kind of a visual inspection. Gary, what are we looking for when it comes to a visual inspection of after the fusion's been done?
I mean, we talked about that double rollback. Well, we want to look for that, making sure the pipe rolls back, that fusion bead rolls back, touches the pipe on both sides of the fusion zone area. We don't want to, sometimes we'll see a bead where it doesn't roll back. It's cockeyed. It's stuck up one side, not all the way down. We maybe didn't use the right pressures and so forth when fusing that together. I think you've got some pictures there on the slides, Will, that the audience can see some of the things that we're looking for there.
uniform beads.
Yeah.
Are they as symmetrical as possible? Are they going all the way back to
Right.
the pipe? V groove not extending more than half the depth of the C. I'm learning on this. all
See,
this
you
stuff,
are,
Gary.
you're picking up that lingo, Will.
And here we're looking at Eric. Eric, how is that bead looking to you?
We've got equal bead widths on both sides. Bead looks great. Everything is centered up. Looks like Gary did it.
I don't know about that, but Gary, that's a pretty high compliment. coming
That
from
is,
Eric.
that is. Thank you, Eric.
So, Eric, for the sake of our audience's valuable time, let's go ahead and pretend that we've waited the requisite 11 minutes or so of cooling time. At what point would you start to load in your next piece of pipe, and how would you get that down the system?
Yeah, so what we would do, first thing is we would unclamp the clamping cylinders, and then we would basically release the jaws from the pipe. We would use our pipe lift rollers on each end. We've got the fixed side roller as well as the movable side roller. So you hydraulic cylinder under each one, you can lift the pipe up out of the machine. You want to make sure that that beautiful bead that we just put between those pipes doesn't get caught between the jaws or the inserts on the way out. So once that pipe is up and supported by the rollers, then you can idle the machine down and you can track the vehicle down the pipeline. Or if you've got a pulling head and you're going to make runs of pipe, you could go ahead and guide your puller to pull that pipe through until the end of the additional piece is in the fixed jaw. And then we would want to lower in a new piece to be attached to the run.
Eric, you've done a phenomenal job helping us out today. Thanks to you and your guys out there. Stay put just in case we have any more questions, but Gary and I are going to talk a little bit about the boring stuff like standards. And thanks so much for all your hard work out there. Keep up the great stuff.
Great job, Eric.
Thank you. Thank you. Thank you, guys.
So Gary, let's go ahead and talk a little bit more about some of the standards that we referenced, kind of starting with the holy grail here of HDPE fusion, which is F2620. What does that entail?
Right. I mean, 2620 is a fusion guideline talking about the parameters specific to HDPE. Doesn't matter what manufacturer, all the pipe manufacturers are on board for all the 4710 resins that we talk about.
Right. Okay.
Our fusion manual, our HDPE fusion manual is all geared on F2620 as a standard basis.
Thank you.
For our step-by-step procedures in that fusion manual.
So there's not only the fusion manual, there's that McCalc app that you spoke about a little bit earlier. These are both great resources for anybody looking to get into the fusion world. A couple of our customers and clients are on the line here, starting some big jobs coming up. This HDPE fusion manual is a must read for anybody. It's really the kind of the quick reference guide for after a training. That is a must to keep in the back pocket.
You're on the job site. It is a great tool. I use it every day. One of those is attached to every rental machine wheel that we send out to a job site. We have a fusion manual attached to that machine so that operator has those guides. He can look up what the fusion pressures that he needs for that size, what bead size does he need to have on that pipe size that he's working with.
So we've also got some quality kind of instruments here that we can use.
Right.
We've touched a little bit on the data logger. Would you recommend a data logger for any big job with HDPE fusion?
I absolutely will. It really helps that operator build that consistency in the fusion weld. It can also alert an operator to a machine problem he may not even be cognizant that he has. I've been on jobs where everybody did everything right, set the pressures properly, did the fusion, had the data logger on there, showed we were about 150 PSI less than what was actually set on the gauge. It had a leak on one of the seals on the cylinder. So he was losing pressure, hadn't had that data logger, would have been blind thinking that he did everything right.
Absolutely.
Yeah.
Gary, we've reached the point in this where I'd love to answer some of the many questions that we have going here. So let's keep this kind of as a rapid fire, if you will.
Bring it on.
Ready. And we'll see how well you fare in this. Brandon is asking, is there a difference between using a manual butt fusion versus this setup?
I mean, there's a difference in the mechanics of the machine. As I stated earlier, your procedures, those 7 steps that we talked about, those aren't going away. It's just how you achieve those 7 steps. You get into the smaller machines, those manual machines, everything's done manually. You're lowering the heater in, you're pushing the pipe together with a pull bar. You're doing the operator's doing all of those functions manually. That was what we call a semi-automated machine. When we get into other machines, then it becomes fully automated.
What typically is the total amount of time to fuse a joint and let it cool? That's from Alex.
Again, going to vary each time by size of pipe. As we talked about, those melt times and those cool times are going to fluctuate based on the size of pipe. So you can go anywhere from, 5 minutes on 2-inch pipe, to an hour and a half on 36-inch pipe.
Absolutely.
So
it's going to vary. It's going to vary tremendously.
Absolutely right.
Little Pipe Mike, our good friend out in the desert, is asking what advancements have been made to make fusion more efficient and help speed up projects.
Oh, my great question, Sundance. I'm telling you what, man. Yeah, he's teed me up for that. So one of the neat things that McElroy's come out with is what we call the I series. Now, right now, it's only on some larger machines that have really automated the process on that fusion process. That drag calculation that Eric had to go through manually, that's all done automatically on that machine. Just hit one button and it calculates that whole drag and adds it right to your fusion pressures. So a lot of neat things are continuing to come out with the fusion process.
And optimized cooling, for instance.
Optimized cooling, right?
These are advancements that are coming out. There's more information, more data constantly being kind of brought up into the industry, which is helping contractors, clients, owners save time and money in the field.
Right. And that's where the ISCO, getting with their local ISCO RSM out there in their area, can work with them and help them and show them all these different tools that are available to expedite and efficiently do their fusion projects.
Great question from Sierra. Can this machinery be lowered into a trench? Ooh. If so, how do you do that safely, Gary?
Nice, Sierra. Great question. So a lot of this equipment is what we call in-ditch capable. Now, you looked at that machine, it's on a chassis, it's got a set of tracks, it's got the generator, the engine, all in one unit. You don't really want to try to put that thing in a ditch. But by removing a couple of pins and unlocking that upper works, we can take that upper works off and put it into a trench to do an in-ditch fusion. We can even remove one of the stationary jaws and cut it down to a 3-jaw unit. ISCO has also created and has available some what we call limited access machines, where we've even got 2-jaw configuration machines that can go in and do those really, really tight fusion spaces. Some places that you'd look at and go, there's no way you're doing a butt fusion there.
And we do it time and time again.
Absolutely.
Take an extension hose kit, put it in the ditch. It's also a safer way to do things because it's constantly going back to safety.
Absolutely.
Mario is asking, is a bend test normally recommended?
Good question, Mario. That really depends on size. If you're doing a 48-inch pipe, it's probably going to be really difficult to do a bend test. As big and strong as I am, Will, I'm not bending 48-inch pipe into a bend test, and it's not very safe. There's other destructive processes, Mario, that we can do out in the field with a side bend tester, where we can cut small strips off of any size pipe and do the side bend test on that pipe that does have an ASTM standard approved with it.
You know, Mario, I've seen on particular jobs where a guided side bend test is specified every Monday because that, helps ensure that the guys that made it through the weekend and are back on the job site are, remembering how to do it. This is a skill like everything else, and you got to, continue to use it to keep good practice.
Yeah.
So really, Mario, it's entirely up to the project. We believe if you've got a data logger, and a certified installer. A guided side bend test is an additional measure that, depending on your level of comfort, may or may not be necessary.
Yeah, I mean, it's a destructive test. And so if you're doing one of those, you're taking a joint that was just completed out of the, and then you've got to redo that weld. So it's not like you want to do one on, you know, a lot of welds. And we use that guided side bend test kind of as a spot check, as Will pointed out.
What is the major difference between butt fusion and electrofusion, Gary?
They both accomplish the same thing, Will. Butt fusion, again, is you're using the machine and you're melting the two ends. Electrofusion coupling fuses on the outside of the pipe. The pipe ends are met in the middle of that coupling, but the fusion occurs on the outside of the pipe. So you're really dependent upon that outside condition of that pipe to properly get a good fusion as well. They both work well. They perform, they have the same pressure capacity capabilities on it, but it's just really the method of how you make that connection.
Tyler is asking the lowest ambient temperature fusion can take place. I believe it's 40 degrees under.
I mean, we've done some fusions at minus 35 out in the plains of North Dakota. It's not a lot of fun to be out there doing that, but you're probably going to need a tent or some type of structure to kind of keep the wind and so forth off of it. But you know, minus 40 degrees is kind of the limit for HDPE anyway. And so fusion, you're not going to want to perform under that temperature.
And really, you want to, at that point, if you have to fuse in sub-zero conditions, if you have to, you know, using heat blankets around the pipe, sometimes you can bring the pipe ends right up to that heater plate, warm up the pipe ends to a little bit more of an ambient temperature before heating it. So there are some things, Tyler, that can be done, but we're fusing pipe all over the world, including up in the Yukon and Alaska, where I've heard it gets a little cold sometimes. Andrew's asking, does the machine allow you to rotate the pipe for an inspection around the entire fused joint, Gary?
It does not. So that pipe is not going to rotate in that fusion machine. So your inspection of your pipe needs to occur before you bring it into the machine. When you lift it up off your pipe pile or what have you, take a look at the pipe ends in the area before you put it in the machine.
And oftentimes a shaving or a ribbon will get caught underneath.
Yeah.
So it's really important to check 360 degrees around that pipe to ensure you've got a workable fusion zone. Our good old buddy Anonymous is asking if butt fusion machines are used to make fabricated fittings. Good question.
They are. We do it in our shop all the time. Now, it's not something that we do in the field with the equipment because it requires special sets of inserts. But we at Isco, we manufacture all kinds of fittings, all kinds of mitered joint connections. We do that in the shop because we've got to sometimes put that pipe in a unique angle that you can't replicate in the field. So if you need a mitered fitting, that's one of those things that you go order from Isco and get that beforehand.
Two more questions here. Anonymous again, chiming in. Thanks for coming, Anonymous. Can butt fusion be safely performed indoors? Yes, it can. However, you want to make sure that the machine you're using is not going to provide any exhaust fumes that could make a dangerous situation. So yes, we do butt fusion all the time, including some aquatherm butt fusion, Gary.
Absolutely.
Indoors, but it really just depends on the machine that you're needing. There is no fume or vapor that comes with the heating of polyethylene.
Nothing with the fusion part. It's
Correct.
just the gas or diesel engines on the machines.
And no flame too. So in some of those applications where maybe you're struggling to weld carbon steel or something indoors, HDPE might be a suitable alternative. Gary, this is a great question here. Can you give an example of the calculations for drag pressure? We touched on drag a little bit, but let's go back and touch on that. So drag is the amount of force it takes for the pipe to move at all, correct?
Right. So we've got a movable jaw on that machine, and we've got a string of pipe out behind. Say we're doing that tie-in. We have a weight associated with that string of pipe. We have to calculate what it takes for that jaw to move with that pipe weight loaded into it. That's what we are determining. It also can be, Will, a drag calculation if we're on an angle, right? and we've got gravity wanting to pull this way. We've got to fight, gravity to be able to pull that pipe upward against the other stationary end. That's what we're trying to calculate, is what we can get that whatever we're fusing to move to the other one.
And you're adding that to the total fusion pressure.
Adding it to the fusion and also your heat soak,
right,
which we always say is at 0. But if you have an associated drag, Eric had it on this one of 60 PSI. So we say no pressure for heating, but he actually had 60 on the gauge just to account for the weight of that pipe hanging out the back end of the machine.
Right. Great explanation there, Gary. I've got one last question for the audience, a final poll question here, and we are nearing the end because there's been such good questions. What are the following topics are you interested in learning more about in the future? Is it butt fusion certification training? Is it questions on our fusion manual, maybe equipment sales, equipment rental, service related aspects, or other fusion support? The reason we're asking, we've got hundreds of Isco employees passionate about fusion and being able to assist. So please reach out to any one of us. We'd be glad to answer your questions as it relates to fusion, because there's simply no way in just an hour would we be able to cover all of it. So it's looking like the most amount of people had questions about the fusion manual, which is great, Gary. That's an easy one. Gary, why don't you bring this thing home? Who is Isco? What do we do?
Right. Well, we'd be remiss if we didn't talk about the company that allows us to be here. It allows us to present to our clients, Isco Industries. We are the largest HDPE distributor in North America. We have offices and locations all across the United States and Canada, ready to serve you with HDPE needs, fusion equipment, whether you need new machines, rental machines, fusion technician services, training. We can provide that for you wherever you're at. We have 24-hour fusion support. So if you're on a job site, something happens, something comes up you're not sure of, you can call that hotline, Will. You can get somebody even smarter than us on the fusion side to help them walk them through on site that process that they're dealing with. So again, this is what we do. We're passionate about it. This is all we do, and we want to be able to make sure your jobs go properly and efficiently.
And perhaps more important, Barrett, follow me here. Let's send it out to Riverport for one final shot of Bradley Cooper fusing. I mean, this is the reason why Isco is what Isco is, because a gentleman like this. Eric, thank you so much again for your assistance and support during all this. Gary, more of a George Clooney,
Yeah.
Robert Redford type thing going on.
There we go. Thank you. Yeah, I like that.
So on behalf of everybody at Isco Industries, please connect with us via these social media channels. There's one of those QR code, I think that's what they're called. You can scan that. It'll take us to our podcast. We're going to keep bringing this up and connecting you with information about HDPE. So I hope you'll follow us on all our platforms and channels. Gary, you've made it to an influencer status. Congratulations.
Oh, awesome, man. I'm moving up in the world, Will.
Absolutely. So on behalf of all my colleagues here at Isco Industries, thank you very much for joining us today to learn about butt fusion. If you have any questions, feel free to reach out to us. In the meantime, stay safe as always and happy fusing. We'll see you next time on Isco Insights.